Dear students, good morning. Welcome back in the class of Engineering Chemistry. I am Asha Pawar, working as Assistant Professor at SNJB Sledsow KPJ College of Engineering, Chandwad, Nasik. Student, today we are going to learn conductometric titration, that is weak acid, strong base, weak acid, weak base, strong acid, weak base. Okay, so the first titration we are going to learn, that is the titration of weak acid with strong base. The common weak acid used, that is acetic acid, and strong base is NaOH. Consider during the titration, that is NaOH is taken in burette and acetic acid in a beaker. So at the initial stage, if we dip the conductivity cell, that is the electrodes used for the measurement of conductance, means platinum, both the electrodes are platinum, reference as well as indicator. At the initial stage, we observed that is the conductance of this acetic acid is lower if we plot the graph conductance versus volume of base, that is NaOH added in ml. So initial stage of the titration, this graph showing that the conductance is lower because acetic acid is a weak acid and it not completely ionized, that's why the conductivity is lower. But as addition of NaOH from the burette, then conductivity slightly increases because the neutralization of acetic acid takes place, that is the reaction happen acetic acid plus NaOH, formation of sodium acetate, and the salt of weak acid strong base is always strong in nature. So due to this formation of sodium acetate, it is a strong electrolyte, conductance increases up to the equivalent point. Then as a excess addition of NaOH from the burette, it is a strong electrolyte, it completely ionized, and that's why conductance suddenly increases after the equivalent point. Therefore B, that is the equivalent point in the graph, that is conductance is not a minimum, not a maximum. At initial stage conductance is minimum and at the end of titration conductance is maximum, means during this weak acid strong base conductometric titration, due to the formation of salt of weak acid strong base, it is strong in nature, up to the end point or up to the equivalent point conductance increases. Okay, then in your practical syllabus this type of titration is there, that is we take the mixture of both strong acid and weak acid and titrate with the strong base, that is strong acid is HCl, weak acid is acetic acid, and strong base is NaOH. If we take the two acid and measure the conductance during the titration with the help of strong base for the two acids, mixture of strong acid and weak acid, we observe the two equivalent points indicated in the graph, that is B and C. So that is, you know that if we take the strong acid and titrate with the strong base, at the initial stage conductance is maximum because HCl is completely ionized, mobility of H plus ion is higher, that's why initial stage conductance is high, that is A. As addition of NaOH, formation of salt of strong acid and strong base, that is NaCl, that is higher mobility H plus replaced by lower mobility sodium, that is Na plus, and up to the end point conductance decreases. Once all HCl is converted into NaCl, then we observe the end point or equivalent point. Then one more acid is there in the mixture, that is acetic acid, weak acid, and it start to neutralize by the addition of what? Strong base. So you know that at the in the titration of weak acid and strong base, at initial stage conductance is what? Minimum. So at the end point of HCl or equivalent point of HCl, it is the initial stage of weak acid, that is acetic acid, and strong base NaOH titration. So at the initial stage of this titration conductance is what? Minimum. As addition of NaOH, conductance increases because formation of strong electrolyte, that is sodium acetate, that is from A to B neutralization of HCl strong acid, and from B to C neutralization of weak acid, that is acetic acid. So at the excess addition of NaOH from the burette, conductance again suddenly increases due to the addition of higher mobility Na plus and OH minus, that is the strong base NaOH. That from C to D is the excess addition of what? Titrant, that is strong base. That's why these two end point are obtained from the mixture of strong acid, weak acid with strong base conductometric titration. It is not in your theory, it is in your practical. So the next type of conductometric titration is the strong acid weak base. Common strong acid is HCl and base is ammonium hydroxide. So consider ammonium hydroxide in burette and HCl in beaker, and we use the conductivity meter and conductivity cell for the conductance measurement. So what happened at the initial stage of the titration? HCl is a strong electrolyte, it completely ionizes. H plus ion is a smaller size and very high mobility. That's why at the initial stage conductance is a maximum. As the addition of ammonium hydroxide, formation of ammonium chloride, that is a salt of strong acid weak base. It is not a strong, that's why conductance decreases up to the end point of this titration, and after the end point or after the equivalent point we again add a excess of weak base, that is ammonium hydroxide. Conductance near about remain constant because it is not a completely ionized. Means in a strong acid weak base conductometric titration, at the initial stage of the titration conductance is maximum, and as addition of weak electrolyte conductance decreases, and after equivalent point conductance slightly increases or nearly constant because we add NH4OH. It is not a completely ionized, means it is a weak electrolyte. Okay, and the last type of titration, that is both the electrolyte we take, that is a weak in nature, that is weak acid, acidic acid titrated with weak base ammonium hydroxide. So if we take these two electrolyte, one in beaker and one in burette, consider here the ammonium hydroxide taken in burette and acetic acid taken in beaker, and we use the conductivity meter and conductivity cell for the conductance measurement. So what happened at the initial stage? Conductance slightly decreases due to the formation of ammonium acetate. Slight common ion effect is observed here and conductance slightly decreases, but as larger amount of formation of ammonium acetate, conductance increases because ammonium acetate is ionized, completely ionized, and conductance suddenly increases up to the equivalent point of this titration, and after the end point or equivalent point, due to the excess addition of base, that is conductance again remain constant because it is a weak electrolyte. Means in weak acid weak base conductometric titration, at initial stage slight amount of conductance decreases, but again it suddenly increases due to the formation of salt of weak acid weak base. It is strong, that is ammonium acetate. So these four type of conductometric titration, that is strong acid strong base, weak acid weak base, weak acid strong base, and strong acid weak base, both all these titrations are important.